Assalamualaikum and good day everyone. In this topic, we will discuss the relationship between embedded systems and robotics which are related to each other. And so to get started, let's start with a little introduction. So a robot system or a mobile robot is considered as an embedded system. Why? Because it has an embedded controller in that platform. So what is the meaning of this embedded controller? So embedded controller or a specialized computer is a combination of computer hardware and software designed for a specific function or within a system that is called an embedded system. And then these embedded systems are also used as computer systems that perform the actions such as monitoring, responding, and controlling external movement. These are called real-time embedded systems, which has been performed on various robotic platforms. And basically, the embedded controller is the heart of any robotic system. So it will receive the incoming information from the sensor, and in response to the information, it will do some mathematical computation and then some decision making to perform or to control its motion in the environment. So many things around us have embedded controllers, okay, such as the things that we carry most of the time, and at homes, even office, right? So these are example of embedded system that has been widely used in the businesses and commercials, in the car. These are some example of the student projects that implementing the combination of computer, hardware and software integration into one system, which are categorized as the embedded computer system. So now we look into the architecture of this embedded controller. The term embedded describes that a computer is embedded inside a complete system or embedded system, which also includes hardware and mechanical parts. This is the structure, the basic structure of an embedded system. We have an embedded controller, electrical hardware, and mechanical. Which the embedded controller is a small specialized computer, which also known as embedded computer. Now we look specifically into the embedded controller, which is part of the embedded system. So in embedded controller, it should contain at least one CPU, or normally also known as microprocessor. And then this microprocessor or CPU is built up together with the memory and I/O to form a basic computer hardware. Okay, that's why we call embedded controller as a small specialized computer. To make the hardware functional and useful, a software program must be placed inside this embedded controller. It may be stored in a non-volatile memory such as flash memory or EEPROM, because it can change because you can change and rewrite the program if necessary. The I/O is used to interface the embedded controller with the physical pins or outside or external devices such as keypad, indicators, LED sensors, actuators, and etc. So this embedded controller also connected with the incoming signal that is received from the sensors, which are usually require analog interfacing because sensors will convert the analog signal that is received from the environment into some readable form that can be understood by the CPU or embedded controller, which is the digital signal. The CPU or microprocessor is always the core component of any computer system. And then with the process of miniaturization, memory and I/O can be integrated together with the CPU on a single chip and become known as microcontroller. Okay, with the combination of CPU, I/O, and memory in a single chip, it can be called as a microcontroller. Now we're back to the embedded system. So in the embedded system, it has an embedded controller, which in this embedded controller consists of software, CPU, I/O, and a memory in a single chip environment. So this basic computer configuration can create so many different applications by customizing the specification or function of the embedded controller, specifically by varying the CPU performance, okay, the CPU platform, either it is going to be 8-bit, 16-bit, 32 or 64 bit, okay, the number of I/O, the software that can be integrated into this embedded controller, and also the kind of interfaces, okay, the type of interfaces that can be connected directly with the embedded controller. It maybe can be connected through USB port, through PCI Express port, okay, to network card, and so on. So the embedded system can be implemented in a mobile robot application. So in this figure, we can observe that the robot architecture shares some similar elements with the embedded system. Okay, for example, if you can see here, the controller here, it can be the embedded controller, which will consist of memories, CPU and I/O. Okay, and then it will be connected to electrical hardware, which can be sensors, motors, actuators, user interface, okay, and then the software here can be integrated with the controller here, and then it has a mechanical structure, which is the base linkages of this mobile robot architecture. So if you relate it to mobile robot architecture here, so you can relate the embedded system with the mobile robot architecture, because mobile robot is also an embedded system according to these elements that has in one embedded system. And that's why we always say that the mobile robot is also an embedded system due to the similar elements that has on both system, right? So normally there are three main areas that normally the embedded system engineer needs to know. Okay, they need to know the processor, the hardware architecture and programming of that system, and then the supporting components that can provide the input and output of that processor and the overall designs of this embedded system. And normally the embedded system will use the general purpose or special purpose microprocessor or microcontroller. The data path of this general purpose microprocessor or controller, it can be 8-bit, 16-bit or better. Okay, and then the system clock speed also differs from one platform to another. And then the number of I/O, you can see here from these three different chips, the number of I/O here, or the physical pins here, are different from for each pins. Okay, meaning that it can be customized. Okay, and then other things that can be customized in an embedded controller is this special functions such as ADC, analog digital converter, pulse width modulation, timer, interrupts, counter, okay, and others. And lastly is the programming methods and facilities. So each of these chips will use a different programming methods or programming language that is specified by each producer. So these are the supporting components in a complete embedded system, which you might design the whole embedded system by using this integrated or discrete components, or with the surface mount or through hole components, okay. And then either the system is integrated with the analog or digital components, drivers and ports. Okay, this is example of ports. Types of power supply, okay, with a different voltage regulating system and so on. And also the design of the embedded controller, it can be divided into two parts. The first one is the hardware development tools, and the second one is the software development tools, because you need to know both system in one complete embedded system. So normally the hardware development tools, it can be an FPGA. Okay, here it can be an FPGA design, or it can be a direct PCB design. Okay, and then normally both system can be simulated before you transfer it into the real implementation. Also, you need to know the software development tools such as the IDE that you use to develop the software or the programming, and then you need to know the assembler or compiler that is used for that certain programming code. And then some of the software development integrated system, they might have a specialized debugger for you to debug the system. Okay, and then lastly is the programmer to program the software that has been written by you and into the real platform of that microcontroller or embedded system. So that's all for today class. Okay, so before we start designing our robot system, we need to know the essential elements in a robot system that make it as an embedded system. Okay, meaning that you need to know the hardware development and also the software that is going to be integrated with your hardware in specific, okay, and to do some certain functions, and so that the robot can become a complete embedded system with a specialized or customized function. Okay, and therefore we'll meet again in the next class, and then we look into the detail of the embedded controller that we're going to use in our class later. See you again.